Alright, for the third video here, we're going to be doing a little bit more applications. And this first one's the area of a triangle using trigonometry. Don't actually need the law of sines for this. Alright, we could have done this in an earlier treatment when we did trigonometry, but it's in this section, so we have some homework problems on it. So let's go through this. Alright, now there's three different versions. Again, looking at what's said here in words at the end of it is how you can read off those three different versions. So the area is 1/2 the product of two sides and the sine of their included angle. Alright, so I'm going to derive I think the first version that we've got in the box there, and what we mean by that is we have these two sides little a and little b, and then we know the angle in between those two. That's they refer to as the included angle. Alright, so let's just derive this real quick and then we'll apply it. Alright, pretty straightforward, the examples we're going to do. So we know the area of a triangle is 1/2 times the base length of the triangle times the height. Alright, now I'm going to assume that the b in the formula here is corresponding to the b, which is the base of this triangle as pictured here. And we're just going to use right angle trigonometry to find the height in terms of the side length A and the angle C. So just using this angle for perched in that lower left or right corner of the triangle, sine of the angle capital C would be the opposite side divided by the adjacent. I said that wrong. Opposite divided by hypotenuse, excuse me. And the opposite side this time is looking straight across from that. And then again, we're going to focus our attention on this, on this smaller triangle here. I'm just going to outline in red the right hand right triangle. Alright, so if we look at that right triangle, the opposite side, and to be able to use sine in this fashion, we have to be talking about a right angle. The opposite side is actually labeled h for the height. The hypotenuse would be the side little a. If we multiply both sides of this statement by little a, it'll clear the fractions, and that allows us to solve for the height h in terms of little a and sine of the angle capital C. Alright, now all we're going to do is take that quantity and substitute it in up above that product in for the height. And if we do that, I'll write it below here, we get the area is equal 1/2 times b times, plugging that in, we get a times sine of the angle capital C. And if we just reorder the factors here, we can drop the parentheses and solve multiplication. Multiplication is commutative. We can order it however we want. We get 1/2 times a times b times sine of the angle C. Alright, so we derived just the first one up in the box here. Alright, and the other ones would have a similar derivation. Alright, it's not worth getting caught up too much in the particular labeling A, B, C, etc. But again, the important thing is you know two sides of the triangle, you know the angle in between them. That allows us to compute the area of the triangle using this result. It's 1/2 times the product of those side lengths times sine of that angle. Alright, and that's what this next example is about. Again, pretty straightforward application. So this one's we're given the angle, and they're referring to it as beta. In the textbook they use beta. I'm going to call that B. We know sides little a and little c, so we're just going to compute the area straight away using this formula. 1/2 times side length A times C times the sine of the angle in between. And you'll notice if you look in the box up above, it's always the product of the two sides, and then what goes inside the sine function is the other angle, which is the other letter. So if we have little a and little c, it's little b inside the sine function. Alright, now we just plug our numbers in. Oh, jeez. Sorry about that. Alright. We get 1/2 times little a, which is 7.2, times little c, which is 3.4 feet, times sine of the angle, which is in this case 42 degrees. So really this is just a calculator problem. The area comes out to, if we work it out here, I'm going to write it down to 5 or so decimal places. It's 8.9016. They're telling us to round to the nearest tenth, so if we were forced to round this off, we would say it's 8.2. Alright, now again, for this is going to be, if this triangle is in feet, this would be square feet, so we'd have 8.2 square feet if we round the value off. Alright, so there's a couple problems in the homework dealing with that area formula. They're pretty straightforward. I want to finish this video with an application problem, and this is going back now to the law of sines. So it says we have a blimp flying over a football stadium. find the height of the blimp if we know the angle of elevation at the southern end zone, point A, and that angle of elevation as pictured is 70 degrees, and the angle of elevation from the northern end zone. All right, so if you think about a football field that's 100 yards, it's kind of out of that end zone. Point B is 62 degrees, that angle of elevation, and we know the distance between A and B is 145 yards. What we're trying to do is find the height of the blimp. We want to know how far off the ground it is. Now for this one, we're going to incorporate another triangle in the picture here, so I'm going to draw that. So assuming the blimp is flying straight, all right, what we're going to do is find this height using, back this up a little bit, using this right angle triangle right here. So pretend these lines are straight here. This, I'm assuming, is a 90-degree angle. All right, now what are we given in our problem? We know the two angles in the figure. We can find the missing angle by adding those and subtracting it from 180. So let's put that in, 180 degrees minus the sum of the other two, which is 70 minus 62, or 70 plus 62 in parentheses. If we distribute the negative like I did in the previous two videos, it would just be minus 70 minus 62. If you compute that, you're going to end up getting another angle here of, the missing angle is 48 degrees. All right, so let's just get that out of the way right away. This missing angle right here in the triangle, the oblique triangle we're given, is 48 degrees. All right, now what we're going to do here is we're going to try to find this height. I'm going to label this H for the height. Now in the picture we have the lower left corner labeled angled A. So I'm going to call this side of this oblique triangle little a. All right, now let's look at the right angle triangle that we've inscribed here. This angle in this corner, well, that's a 90 degree. If we include the 62, that'll be a 90-degree angle. All right, from here to here. All right, so what is 90 minus 62? That is 28. So this angle right here, not angle little b, or capital B, which is 62, this angle is 28 degrees. All right, so if we use our right angle trigonometry on the right triangle that I drew into the picture, it would tell us cosine of that angle, 28 degrees, will equal the adjacent side length, which I'm calling little h, divided by the side length little a, which is the hypotenuse of that right angle triangle. Now multiplying both sides by little a of this equation and flipping it, we would get that the height is equal little a times cosine of 28 degrees. All right, so that was from right angle trigonometry. Now, do we have enough information in the problem to find side length little a of the oblique triangle? For that, we're going to use the law of sines. Okay, because we know 48 degrees, the angle capital C, and we know the side length across from it's 145 yards. We know the angle capital A is 70. We can use the law of sines to find side length little a, and then we will simply substitute it in right here. All right, so let's write that out. All right, so I'm going to go down a little bit and we'll put that in here. So again, what we're saying is we're going to use this version of the law of sines. I actually want to use it just to speed things up here. I'm going to undo this. I want to use the version where we had the reciprocals in there. So I'm going to do the side length on top, so little a on top, divided by sine of the angle capital A will equal little c divided by sine of the angle capital C. Now let's plug our numbers in. We don't know side length little a. We're going to figure that out. We know the angle capital A is 70 degrees. Side length little c across from angle capital C is 145 yards. And then the angle capital C is 48 degrees. The degree symbol off. Okay, now from here, let's simply clear the fractions by multiplying both sides by sine of 70. We could cross multiply and then divide too. That's perfectly fine. Here the sine of 70s will cancel, and that will give us the angle, or the side length little a. It's 145 divided by sine of 48 degrees times sine of 70. All right, and that's what we were missing, the information we were missing. Now we can plug that into a calculator and then plug that in up above and multiply by cosine of 70, or we could let the calculator handle all of this. So I'm just going to take that approach to it. I'm going to take that whole quantity and then substitute it in here. And now let's write that out and then plug that in. All right, so the height h we knew was little a, side length little a, times cosine of 28 degrees. I'll leave the degree symbol off. We just found little a. Leave myself some more space here. That's, yeah, I guess I'm going to put that in parentheses. That was 145 divided by sine of 48 degrees times sine of 70 degrees, and we're now going to multiply that then by cosine of 28 degrees. All right, so that's a good way to approach this. Just plug all of that directly into your calculator, and you will get, all right, and that'll give you the most accurate answer. We will get, in this case, 161.8882. I'll just stop there. All right, so if we want to round it to 1 or 2 decimal places, we can do that. Okay, and in this case, we just found a length that was yards. All right, so that's how many yards off the ground the blimp was. All right, so let's just review this briefly here. There's kind of 2 steps to take for this problem. One was to realize to find the height we wanted. We could get that with right angle trig with the triangle that we drew in, but we needed the hypotenuse, all right, of that right angle triangle. We found that hypotenuse from the given information using the law of sines. There's kind of 2 steps to take here for this problem. All right, that's it for this video.